Uses of capacitors. Capacitors can be used to store energy over a relatively long period of time, then release this energy over a much shorter timescale. In a camera flash and in a defibrillator, the device used after someone suffers a heart attack, there are transformers and oscillators that we're not going to go into, which allow a capacitor to be charged to a very high potential difference of up to 1000 volts and more from a battery of as little as 6 volts. This will occur over a few seconds at a relatively low power. The discharge then takes place over a very short time period, and therefore a much higher power. For example, if a 300 microfarad capacitor is charged to 1000 volts over 10 seconds, the energy is given by half CV squared, which gives an energy of 150 joules, meaning this was an average power as energy over time of 15 watts. If the discharge then takes place over 3 milliseconds, for instance, again power is energy over time, which is 50,000 watts. A pacemaker battery will also charge up a capacitor, but this time to a much lower potential difference. For example, if a 2.5 volt pacemaker battery charges a 5 microfarad capacitor over 1 second, the energy will be equal to 1.56 times 10 to the minus 5 joules. The power then, as energy over time, is 1.56 times 10 to the minus 5 watts. If the discharge takes place in 1 millisecond, a thousandth of the time of the charge, then the power is going to be 1000 times greater. Capacitors are also used as timers in pacemaker circuits. The charging rate of a capacitor through a resistor is entirely predictable, and so by connecting a capacitor to an electronic circuit which requires a particular potential difference to turn on, a set time interval can be produced. If a pulse to the heart is needed every second, for instance, a capacitor-resistor circuit can be used that takes 1 second to reach the required potential difference. When this value is reached, the capacitor will be discharged through the heart and then start charging again. I can show that complete process with this much simplified diagram. We have a power supply in series with a resistor and the capacitor. The capacitor will charge up. When it reaches the required potential difference, circuitry will close the switch, bringing it in a circuit with the heart. So the current will pass through the heart. When the potential difference has dropped below a particular value, the switch will reopen, allowing the capacitor to charge up again. The potential difference reaches the required value, the switch closes, the charge passes through the heart, the switch then opens, the capacitor charges, and so on. So this system allows a precise current to pass through the heart at a precise time interval, keeping the heart beating at its required frequency.